Alright, so this is a lesson on exponential growth and decay, and we're going to start out by talking about exponential growth first, then we're going to talk about compound interest, and then we'll finish up with exponential decay. Alright, so exponential growth can be modeled by the equation y equals a times b raised to the x. Okay? There are some restrictions. A has to be greater than 0 and B has to be greater than 1. And these restrictions are specific to the growth formula. Okay? Alright, the base B is the growth factor, which equals 1 plus the percent rate of change expressed as a decimal. So if we were given a problem where it had 7% growth and the initial amount was, say, 20, and the constant A represents the initial amount, then we would be able to write the formula as y equals 20 times, and it would be 1 plus, we need to change the 7% to a decimal, so that becomes 0.07. So that would be 1.07 raised to the x power. Okay, so that's what it's talking about when it says 1 plus the percent rate of change expressed as a decimal. All right, let's take a look at a few examples here. All right, and in example 1 says, since 2008, the amount of money spent on music downloaded has increased about 9% each year. In 2008, about $3.7 billion worth of music has been or was downloaded. If the trend continues, about how much will be spent on music downloaded in 2018? So we're going to start out with the equation y equals a times b raised to the x. The initial amount is going to be 3.7, so we substitute that in. The b, this b would be 1 plus the rate expressed as a decimal, which this is going to be 1 plus 9% would be 0.09. So in there we would have 1.09. And this would be raised to the x power. Okay, but we actually know x in this problem, so instead of leaving it as x, let's go ahead from 2018. From 2008 to 2018 is going to be 10 years. So we substitute that in, and we end up with approximately $8.76 billion worth of, so it's $8.76 billion worth of downloaded music approximately in the year 2018. Okay, and one other question that I want you to think about for tomorrow. What would the formula look like if we changed the percent to 7.5% and the initial amount to 5.2 billion? So kind of take some notes, think about that, and be ready to discuss that. All right. In example problem 2, we're going to talk about compound interest. So suppose that when you were born, your parents deposited $500 in an account paying 3.5% interest compounded quarterly. Okay. What will the account balance be after 18 years? So first thing we need is the formula, and this is your compound interest formula. Which is A equals P 1 plus R over N to the NT. Now to the side, we'll talk about this. A is the amounts in the end. P is principal, or the original amount. R is the rate, and we're going to change that to decimal. N is the number of times compounded. And T is the time in years. So let's just go through and substitute in what we have in this problem. We've got $500 as our principal amount. The percent, 3.5, we have to convert over to a decimal, so that becomes 0.035. It's going to get compounded quarterly. Quarter is 4 times a year. And then it's being raised to the power of 4 times 18. So when we go to put this into the calculator, we can type this in just like this, and then raise it to the power of 72. Go ahead and multiply the 4 and the 18 to get 72, so that when you plug it into the calculator, we should get an answer of $936.24. Okay. All right. And what I want you to think about for tomorrow's class is I want you to think about how would the amount change if it were compounded monthly. All right. So think about that on your own, and we'll talk about that tomorrow. What we're going to talk about last is the exponential decay. All right. So decay has the same equation. It's modeled by y equals a times b raised to the x. The only difference between the exponential growth and decay is the minus. Okay. So if we take that same type of problem, 7% decay, we have the initial amount being 20. Instead of adding 0.07, we're going to subtract. So it would be y equals 20, and then 1 minus 0.07 would be 0.93, so that would be 0.93 to the x. Okay, so that would be the equation that we're working with for that particular problem. All right, in the third example, all right, we've got the amount of bacteria in a population decreases by 10.5%. So there's our percent. Every hour at the initial population was 2,000. This population after 3 hours. So we start out with the equation y equals a times b raised to the x. Initial amount 2,000. Our b is going to be 1 minus 0.105, which would give us 0.895. X represents the time, so we're going to have it raised to the third power. And that would then give us a value of 1,433.83475, which we would then round to approximately 1,434 bacteria. Okay, so there's our answer for example 3. All right. And what I want you to think about in terms of that particular problem for tomorrow is what would the term half-life, okay, this term half-life mean in a problem such as the one above. All right. So be ready to discuss those 3 questions that we talked about in this lesson, and there's a lesson on growth and decay.